Everything you need to ace science in one big fat notebook. Science. Chapter 3. Lab reports and evaluating results. It's important to share your result with other scientists so they can learn from your work, critique it, and build upon it. That's how science knowledge grows. There are many ways to communicate your experiment and finding to others. The most common way is to write a lab report. Writing a lab report. A lab report usually contains the following. Title. Let the reader know what the investigation was about. Purpose. A brief description to answer the question, what was the purpose of doing this experiment? Or what's the question I'm trying to answer? Background information. Definition of key words or an explanation of key concept. Hypothesis. The predictions you were testing. Materials and equipment. A list of the materials and equipment necessary to carry out the experiment. You could even add a sketch or description of the setup. Procedure. A step-by-step description of how to carry out the experiment. Data. All the measurements and observations you made during the experiment. Be sure to present data in an organized way, such as in table, graphs, and drawings. The best measurements are accurate and precise. Make sure to title chart, graphs, and tablet and to label all axes on any graphs. Precision. How consistent and exact your measurements are. Accuracy. How close to the actual value your measurement is. Conclusion. A summary of what you learned from the experiment, whether or not your result supported your hypothesis, any errors and questions for more experiment. Sometimes exact measurements are not possible or practical, like if you don't have the right tools to measure something or if a decimal continues to infinity. If that is the case, sometimes scientists use estimation or routine rounding numbers. Estimation, a rough guess of a measurement using region and observation. Rounding numbers, giving a number of nearby value. For example, if you are rounding to the tens place and the hundredth digit is 5 or more, round up. If the hundredth digit is 4 or less, round down. Evaluating scientific result. When reading another scientist's finding, think critically about the experiment. Ask yourself, were observations recorded during or after the experiment? Do the conclusions make sense? Does the data conclusively prove the hypothesis, or are there other ways of interpreting the data? Can the result be repeated? Are the resources of information reliable? You should also ask if the scientist or group conducting the experiment was unbiased. Being unbiased means that you have no special interest in the outcome of the experiment. For example, if a drug company pays for an experiment to test how well one of its new products works, there is a special interest involved. The drug company profits if the experiment shows that its product is effective. Therefore, the experiments aren't objective. they might ensure the conclusion is positive and benefits the drug company. When assessing result, think about any biases that may be present.